Dear students, how to determine the Jacobian matrix of an isoparametric element? Let us discuss in this lecture video. Determine the Jacobian matrix of the quadrilateral element whose Cartesian coordinates of the corner nodes are given by 0, -1, -2, 3, 2, 4 and 5, 3. Evaluate the Jacobian matrix at the point 0.5, 0.5. Four corner points of a quadrilateral element are given. From the graphical arrangement, we can name the nodal points. One as 0, -1, the nodal point 2 as 5, 3, the nodal point 3 as 2, 4 and the nodal point 4 as -2, 3. It is asked to formulate the Jacobian matrix for the given quadrilateral element at the local points epsilon and eta 0.5, 0.5. The Jacobian matrix formula for the quadrilateral element, here the isoparametric element J is J11, J12, J21, J22. The formula for J11 is, formula படிக்கிறதுக்கு கொஞ்சம் ஈஸியா இருக்கணும்னா இப்படி ஃபாலோ பண்ணிக்கலாம். These are the shape functions of an isoparametric element. J11 formula is 1/4 into இந்த எப்சிலான் டேர்ம்ல உள்ள சைனை ஃபுல்லா அப்படியே எடுத்துக்கலாம், ஈட்டாவோட டேர்ம்ஸ் அப்படியே எடுத்துக்கலாம். To set the formula for J11, so for the first term the sign of epsilon in N1 is minus the term eta, here 1 minus eta x1, plus in the second shape function the sign of epsilon is plus, the second eta term is 1 minus eta x2. Then in the third shape function the sign for epsilon is plus and the third eta term is 1 plus eta x3. In the fourth shape function the sign for epsilon is minus and the fourth eta term is 1 plus eta x4. Likewise, we can keep this formula in our mind. In the present case, the Jacobian matrix has been asked to evaluate at point 0.5, 0.5, so the epsilon and eta values are 0.5. The coordinate positions of the quadrilateral element are given in the problem. By substituting the given values in the formula, we can calculate the J11, that is the 1 component of the Jacobian matrix can be calculated as 2.125. Then to calculate J12, we can use this formula. In the J11 formula, just by replacing the x1, x2, x3 and x4 components by y1, y2, y3 and y4 components, we can have the formula for J12. By substituting the values and the coordinate positions given in the problem, we can calculate the value of J12 as 0.875. Next, the formula for J21 is like this. In the formula mindla vachikkiradhukku, again we can consider the shape functions of the isoparametric elements. Here J21 formula la ulla ovvoru termukkum we have to consider the sign of eta in the corresponding shape function and the epsilon term. Okay, for example J21 formula la first term வேணும் அப்படினா first shape function ஓட eta sign, that is minus, so here minus the first epsilon term, that is 1 minus epsilon. For the second term in the J21 formula, in the second shape function the sign of eta is minus and the second epsilon term is 1 plus epsilon. Okay. For the third term in the J21 formula, in the third shape function, the sign for the term eta is plus and the third epsilon term is plus 1 plus epsilon. For the fourth term, in the fourth shape function, the sign of eta is plus and the fourth epsilon term is 1 minus epsilon. By substituting all the known values, we can calculate the value of J21 as minus 1.375. Next, to calculate the value of J22, we can use this formula. This formula can be obtained just by replacing the x1, x2, x3, x4 components in the J21 formula by y1, y2, y3 and y4 components. Okay. By substituting the known values here, we can get the value of J22 as 0.875. We have calculated all the values to assemble the Jacobian matrix. So the Jacobian matrix for the given quadrilateral element is 2.125, 0.875, minus 1.375, 0.875.